Hi, I'm Narendra Kumar. I have 12 years of experience in IT with 8 years in data engineering. I have completed these architect level certifications, and recently I became a Databricks Solutions Architect Champion as well. In this video, we are going to build a data engineering project end to end, all in Databricks Free Edition. I will also be sharing all the code and data files so that you can also build this project on your own without any cost. These are the technologies we will cover. For data ingestion, we will use autoloader, Apache Spark, JDBC connections. For transformation, again, we will use Spark, SQL, Delta Lake, Databricks notebooks. For orchestrations, we will use Databricks Jobs. For governance, we will use Unity Catalog. We will build our own custom emails. For data consumption, we will build a Databricks dashboard, Genie workspace, Databricks One also we will understand. We will set up our own secret scope, and all these things we will build this as a framework which will be metadata driven. First of all, we will go through the business use case, then we will understand its architecture, then we will understand the source tables, the metadata tables. After that, we will set up our source with these files that I have shared. Then I will explain each and every notebook line by line, where we will first set up our metadata, source to silver ingestion we will do, then gold transformations we will perform. Then this notebook is for email notification. This is the kind of email we will be getting at the end. To orchestrate, we will be building these Databricks jobs, which will be nested with multiple levels, and we will also build a nice dashboard from scratch with different type of visualizations. We will also set up a Databricks Genie workspace where user can query anything using natural language. We will also go through this Databricks One, why it is used. So all these things we are going to cover. I hope you are already excited. So let's get started. Let's start by understanding the business use case, which means like why exactly the client they need this project. So let's assume our client is Neobank, which is a virtual name I have taken. It generates large volume of data from its core banking system, payment gateways, and external credit bureaus also send data to this bank. This data it is currently spread across multiple platforms, and it is available in different formats. So it is making it difficult for a unified analytics, and business teams they need like a combined overview of their customers, their branches, everything, which is currently not possible. And the problem it is the same, that data is spread across multiple sources, the volume is huge. So due to the scale problem, building manual pipelines for this data processing will be slow, complex, and hard. And business users they currently lack self service analytics, a combined overview of this data. And the solution approach we have taken to solve this problem is that we have built a metadata driven framework on Databricks that uses a medallion architecture. We will be building a bronze, silver, and gold layer. And for that, we have integrated two sources. One is SQL Server, another one is cloud storage into unified analytics platform. This will become a platform which has the data of both these sources and ready to use analytics there. And for or to serve the business users, we have created their interactive dashboards and Genie AI interface for business users. So dashboards, they can see an overview or the reports. And in Genie, they will be able to query the data based on natural language. Like they can ask who is the most important customer, which branch or which branch is performing best. Like that, they can ask any question they want. So this is the use case or the business problem that we are going to solve. Next, let's understand our source tables quickly. So in total, we are going to use 4 source tables. 4 are there in SQL Server and 2 we are going to ingest from blob storage. And blob storage, it is kind of like a file storage only. So we will be using Databricks volume only for this. For SQL Server, we will be using a free edition, which anybody can set up very quickly in Azure. So in SQL Server, the tables we are going to create will be related to branches, which will contain the information about the branch of the bank, like branch name, city, state, etc. Then customers table, it will contain customer related information like their name, date of birth, phone number, like that. And account, it will contain their account related information. Like one customer can have multiple accounts also in the bank. So their account ID, account type, their balance, and everything. And then whatever transaction they are doing in their accounts, that information will be there in the transactions table. So these tables will be there in the SQL Server that we will be ingesting. And then two tables which are coming from external sources will be ingesting them as CSV files. So one of them is credit bureau reports. So like that, we get uh, ratings depending on their PAN card from external parties or credit bureaus, like what is the credit score of the customer, what is their risk grade. So that kind of information we will be getting as CSV files. And then whatever transactions are happening, so whatever payment gateways customers are using, like credit card or ATM, so from those external sources we will be getting the payment gateway logs as well, which we will combine and then get an overview or a summarized analytics on our data. Next, let's understand our architecture, how exactly we are going to build this project. So these are the two sources, as I explained, we are going to use. To ingest the data from these sources, we will be using autoloader to ingest the CSV files which are there, and it is part of the Apache Spark. And to ingest the data from SQL Server, we are going to use a JDBC connection, and that we will be writing as a Databricks notebook. After the data is ingested, then we will be building a medallion architecture with data transformation. So whatever raw data we will be getting, first we will be putting the data into bronze layer. After that, we will be merging the data into silver layer based on like incremental load or full load. And once all the data is available in silver, then we will be building gold layer table, which will be the real analytics that is required by the business users. And to do these transformations, we will be writing Databricks notebooks. We will be using Apache Spark, PySpark code basically, and all these tables will be made available as Delta Lake tables. And then to orchestrate this process like data ingestion, transformation, and even dashboard part, so there we will be using Databricks Jobs, which will first perform data ingestion, then transformation, and then refresh our dashboards as well. And also it will be metadata driven. That means it will be a reusable framework, so that like in future we can add more tables automatically just by adding the metadata. And it will include auditing information as well. After every run we will be capturing really good information there. And for this metadata DB, even we can use any external SQL database like Azure SQL DB, or if we are working core on Databricks, then we can even use like Delta tables also as metadata table and auditing table. That's what like I will be using during this project. And for the governance part, so Unity Catalog we will be utilizing for creating our all the tables, all the volume for these files, and overall control of this process. And then after every ingestion into bronze, silver, and gold, we will be sending very customized emails that will give us a summary of the ingestion, like which tables are ingested and what is their status, and with lot of additional information as well. And after the data is made available on the consumption side, we will be building a Databricks dashboard with multiple pages, and which will really serve the business users for their use case. And then we will also build a Genie workspace where user can ask any question in natural language. They will get their answer in natural language, and it will also create some visualization as well automatically. So this is how we will be building this project end to end, from data ingestion to transformation to serving, orchestration, and governance, everything combined into one. Next, let's have a look at our metadata table, which will make our framework reusable. So these are the four tables we will be creating. The first table, it will be the tables, like the name suggests, it will contain the information like table ID, what is the name of the table, the source schema and source system and source path if it is a file, and what is our target layer, whether it is silver or gold, and the name of the bronze, silver or gold schema depending on the table, in which order we need to load them. These will be the basic information related to each and every table, like the 6 tables we have for silver, and then 4 tables we will be building in gold. So for each of the table it will have one row in this particular table. And then in the table parameters, we will store some parameters related to each of the table, like what is the load strategy, and what are the primary keys or merge keys. So those kind of parameters we will be storing. And this will be a generic table with parameter name and value. In future also, we can add any additional parameters here. And in the table watermarks table, we will be adding the last watermark value, so that for incremental load, we can directly fetch it from here and then use it in the next run. And this will be our auditing table. For each of the table ingestion, we will be noting like the run ID, the table ID, which layer the table belongs, its start time, end time, status, number of records. And if there is a failure, then it will log the error message as well. So all this information we will be capturing in the table, which we can have a look directly. And this table we will also be using to send our customized email as well, with a summary table in our email. So this was all the theoretical part that I wanted to explain. Now let's jump to the demo and let's build this step by step and make it work. First of all, we need one source to ingest the data. For that purpose, we are going to set up our SQL database. It will be a Azure SQL Server database. I have just created the SQL Server and the database inside it, which is very easy. You can find any video and simply create it. And as you can see in the pricing tier, it is free. So it is available for free. Anybody can simply create it. And to create the tables inside it, we need to go to this query editor. And then I will use my own user. So currently, as we can see, we don't have any table available here. And in this project repo, I have included these files for SQL Server. So first of all, we are going to create the tables. So this is the script which will be used. So we just need to copy paste it there and just run it. So I'm going to copy it and run over here. That's it. So now our tables are created. 4 tables are created: accounts, branches, customers, and transactions. So currently these tables are blanks. Next, we need to insert some data into these tables. For that, I have created another script. So I have created one script for historical data load and one for incremental data load. So first we are going to insert historical data only. We will ingest it. Then we will run for incremental data load, so that we can understand how does the incremental load works. So I have pasted this entire script here. I'm going to execute it now. So this will insert the data into all these tables. Now the data is inserted. So let's check out some sample data. Let's create some new query. If we check the branches table here, it will show us the branches like branch code, branch name, which city, state, region, and when this record is created. Similarly, the accounts table, it contains the information about account like account ID, account customer, its type, how much balance is there in the account, which currency it is using, branch code, all that information it is available here. And then in the customers table, it will show customer related information like what is customer ID, their first name, last name, date of birth, PAN number, email, phone number. So everything it is showing, and this is virtual data. So don't use this data for anything else. Next, checking out the transactions table. This one, it include the transaction related information like transaction ID, account ID, transaction type, how much amount the transaction was for, when it was done, which channel was used, and all. So this kind of information is here. So now our SQL source, it is ready. So now let's understand how we can ingest the data from this SQL server into our Databricks table using our metadata driven framework. Now coming to the Databricks workspace, I have included all these folders into my repo. You can copy them. So these include like setting up our metadata so that we can build the metadata driven framework. Then the notebooks for source to silver that we are going to use with this framework. Then the notebooks for silver to gold for the gold transformations. And then the notebook that we will use to send our custom email. So these are the notebooks I have already included. Let's start first by setting up the metadata. So this is the notebook I have currently open, set up metadata. So these tables I have dropped, which I had created previously. First of all, we are going to create a catalog with the name banking. And inside this catalog only, we will create multiple schemas, one schema for metadata, and also we will create for bronze, silver, gold, and we will use it as a source also for our CSV files. So for the setting up metadata, we will first be creating a schema with the name metadata. And inside this schema, we will be creating our metadata table. So first table, it is tables table with these column like I was explaining previously in the metadata model. So it will contain one entry for each of the 6 tables we will be bringing in from source, and also 4 entries for our 4 gold tables. After making the entries, we will understand what is the content so that it will be more understandable. And then we will create one table to store the parameters for those tables. And then this is the table which is watermarks table to store the watermarks for incremental load tables. And then this will be our audit table to store the audit information like start time, end time, run ID, number of records, and everything. So I'm going to run it so that it will create all these tables for me. Now the tables has been created. Next, what we are going to do is we will be creating a volume. So volume, it is like a blob storage. So like we have a blob storage, we mount the blob storage in Databricks. So similarly, we can connect the blob storage into a volume as well. So it will act as a blob storage for us. So we are going to create a volume here. And after that, we are going to insert the metadata into our tables. So from here onwards, I will run all the cells below. These will insert all the metadata which will be required. And after inserting, let's review what metadata is available for us. Now this cell is completed. This one is also completed. Yes, so looks like all the metadata is inserted now. Next, we are going to go to this notebook and check the inserted metadata. So in this notebook, first of all, let's check out our tables entries. So here we can see it has made 10 entries here, 4 for the SQL Server tables, which we just created, 2 for the tables which will be coming from blob storage, and then 4 for our gold tables. So let's understand these one by one. For our SQL Server table, this is the table name, source system is SQL Server, source schema is banking. That's where we had created our tables. This is the name of that source table. Path is not required. It will be there for blob storage. And then the target layer for SQL Server, it will be silver layer. So first it will be ingested to bronze, then silver. So target is silver here. And these are the schema name. So where the tables will be created. So bronze table will be created in the schema named bronze. Silver will be created in the schema named silver. This is not for gold, so it is null. And active flag is true. So this one we use like in future if you want to disable some table. So simply we make it false and that table will be disabled. So by default we are keeping everything as true. This is the order in which these will be processed, and these can be processed independently also. So we can either use this column or discard it, it's up to us, but it's good to have it here. This is when the entry is made. And then similarly for blob storage, these are the 2 tables we will be ingesting. For these, there is no source schema or table. The files only are there. This is the path for those files, and rest of the entries are exactly same as SQL Server. And for gold tables, these are the 4 entries. The source system for these is silver layer for gold tables. And there is no source schema or source table required here. And then this is the source path, which is also null. The target layer is gold for gold layer, obviously, and bronze and silver schema will not be required because these tables will be created in gold layer. So this is there. So like this, the metadata entries are there. And when we will be calling these through our reusable jobs and notebooks, that time this column is will be very important. So whenever we will pass the variable source system equal to SQL Server, it will process these four table. Whenever we will pass blob, it will process these two table, and whenever we will pass silver, then it will process these four tables. That's how we are going to use these. Next, moving on to the parameters table. So for this table, we have added some parameters as well, and these are linked using these table IDs. So for example, the first table, which is customers, for that one, we have these three parameters. Like load type, it is merge strategy. That means whatever new column new rows we will get, we will insert, and if we get the same rows, we will update them. And to update them, we need a primary key. So this is going to be the primary key. And then we need a watermark column as well to bring in incremental data as well. So this is our watermark column. So for most of the tables, we will have these three columns. If you see, like for table one, second table, like which is account table, so same details are there. The third table, which is transaction table, so the load type, it is append, because transactions, once it is made, it is never updated. So only new transactions, we will insert them. And then our branches table, that is a full load. So it is a small data. Every time we can do a full load. And as it is a full load, so for that one, we don't need a watermark column for that one. And then this is customers table, it is merge. And then this is our six number table. Let's see which table it is. It is payment gateway logs. So for this one, like the strategy is again append. So that's how like these entries are there for each and every table. And the next table which was created was this pipeline runs. So this is currently blank because we have not run anything. And next one here, this is the same two tables, like the tables table and the parameters table. I'm just joining these and checking. So the table wise, we can see which merge strategy we are, load strategy we are using. So as we can see here, so three tables will be using a merge mode, and then two are up with the append mode, and branches is full load. So that's how we will be loading the data. And then we are left with one more table, which is our uh, watermarks table. So let's check that one also out. So this table, it will store the watermark value. So what is the last watermark value when it was updated, and what is the last run ID of that run. So that way it is there. By default, it is like 1900. So that from this date onwards, it will bring in all the data. And after bringing in the data, let's say if we will run it today, then it will update today's date here, so that next time it can use this date as a where condition while pulling the data, and from that date onwards only it will bring in more data. And as we can see here, like for the full load table, we don't need a watermark value, so that's why there is no entry for 4 others. We are making entry here. And these entries, mainly these three, will be used for SQL Server. These two, even though I have added, these won't be used because we will be using autoloader to bring the data from blob storage. So these are just dummy entries. So now as we understand our metadata model, next let's check out our reusable notebook for bringing in the data from source. And these are the notebooks that I have created. So first of all, what we are going to do is we are going to set up a secret scope. And why we need a secret scope? So in production, we cannot store our secrets into like notebooks. So that is why we create a secret scope in Databricks and put our credential there. So here currently we see some dummy entries. So to connect with our SQL Server, we will need its host name, its port is always same, the database name, username and password, which we can get it from Azure and then update here. This secret scope name, it can be the same, like it will create a new secret scope with this name, and then it will insert these details. And the key name, like inside a secret scope, it store the values as key value. So this will be the key that I have given. We can give any name also, and inside the value, these will be the entries that will be stored. And to store all these entries in a single key, we are going to make it as a JSON. So this is the JSON I have created, like all these values like host, port and whatever I showed you, along with the driver name. And then this is a config, and then I'm creating a JSON out of it like this. And this JSON I will be storing there. And to store there, first of all, like I'm getting a context and token. So here we don't need to make any change. For your workspace, automatically it will pick up all these details. And then it is like setting some variables, and backend type, it will be Databricks. That's where we are creating. And secret scope, those can be also two types. So in our project, we will be creating them in Databricks only, and internally it will store our secrets. And optionally, we can also store our secrets in Azure as well. So for that one, we specify Azure Key Vault. But for that one, we will need some additional details. So for now, we will be using the Databricks backed Key Vault. So normally in this is a admin task which is done. So what I have done is I have just directly written this notebook so that you can simply put your details here and just run this notebook once, and it will set up everything. And if you are so just to explain some high level details, first of all, it is going to create a secret scope for us if it is not there, and then it will show that the secret scope is all created successfully. I have already run this notebook so that I don't have to run it again and again. After creating the secret scope, next what we are going to do is create a secret inside it. For that one, we are calling this API secret/put. And here again, we are passing the token which is fetched dynamically. And then this time, like the scope name, we are passing the same, like banking scope. Secret key, this time we are passing the key name which we had given, like this is the key name that we will be using. And then in the value part, we will be providing that JSON here. So in the payload, if we see, so scope, secret key and secret value is that entire JSON. So that is what will be stored there. And after running this, we will see that this secret, it is created successfully inside this scope. And to confirm that it is created successfully, I have also written this code. So this is just like getting those secret. And within our notebook, actual like PySpark code, we use this DB utils to get the value of the secret. That is what I'm doing here also. So like dbutils.get the name of the secret and the key of the secret. And then as we are getting it as a JSON, I'm parsing it and simply printing here to confirm that it is stored successfully. And here you can notice that I have given here the name as dummy, because in the without dummy, this original string, I have actually stored my own SQL Server connection that I don't want to show here. That's why for this run, I'm showing this dash dummy. But when you run it, remove this dummy and then put it with this actual name. So this is the secret, we have kept it, and we can see that it is coming back as well. And in the next cell, we are adding something called as Gmail API key. This one we will come back later on when we will talk about email notification. But here simply we are storing a API key to send the emails. This we will cover in more detail later on. So here, as we have set up our secrets, so next let's understand the rest of the notebooks and what they are doing. So to ingest the data from source to branch, as we were talking about, we are building a framework. So that's the reason first we have built one notebook that will read the list of tables from our tables table. After that, it will read the parameters for that particular table one by one in a for loop. And then for each table, it will run this notebook to ingest the data. That's how high level it will work. And all the dots will be connected when we will build a job and call these notebooks one after the another. That we will build a new job and we will see in more detail. First, let's understand these individual notebooks. So first, this notebook, it takes only single parameter, which is source system. But the default value, I have kept it as SQL Server here. So here I'm just creating a widget. As we can see here, we are getting its value. If it is not provided, it will throw an error. After that, we are just creating a data frame of our tables table that we had created. And then we are applying a filter, like where source system is this based on the input and active flag is true. So those entries it will return. So that whenever we pass SQL Server, so those 4 SQL Server tables will be passed in. Whenever we pass blob, so 2 blob tables will be passed. And whenever we pass silver, so then silver to gold 4 tables will be passed in. That's how this particular notebook will be used. After we get these rows, it will display them. And then uh, to pass it back as a output. So here first we can display and see for ourselves. Maybe let me run this also so that I can show that part. And as we can see here, after that, let me show these entries. So for SQL Server, we can see those same 4 entries that will be required. And now to when we will be building a Databricks job, so how it will work is this notebook, it need to return this list as a JSON output so that that can be used in the next step. And then those output parameter will be passed to the next notebook. So to return the output value, we have this particular method, which is available as dbutils.jobs.taskvalues.set. So what it means is whenever this notebook is called from a job in Databricks, so at the end of the task, it will set these values as the output of the task. And in the output, we will be able to see that this is the key, which is tables underscore metadata. And the value, we need to pass the list of tables. So this will be the list of tables we will be passing. And to prepare this list, it normally takes a JSON. And to prepare this JSON, this code comes into picture. So here we had a data frame. That data frame we are collecting. And then for that data frame, we are getting it like a row by row. So this is a array and we are passing it like a row by row, like 4 row in rows, these rows. Each of the row, it will do this. Inside this current, first it is preparing it as a Python dictionary. This is a array, like square bracket means array. And this means like a single entry within that array. And that single entry, it has key value pair. So table ID, first table ID, table name, first table name. So like that, it is preparing this JSON. And all 4 tables, it is adding one by one as a JSON. And then finally, the big JSON, it is preparing like this. Here we can see the combined output of those 4 tables will be returned as a output. So that is the functionality of this notebook. And to understand it better, let's start building the job also in parallel so that we can understand how the output of one notebook will be passed to next and how it can be used. So now let's go on and let's build our job from scratch. To build the Databricks job from scratch, we need to go to this section, Jobs and Pipelines. Here we click on this create icon. And here we see these 3 different entries like job, ETL pipeline and ingestion pipeline. So this ingestion and ETL pipeline, this is something new and emerging. This job, it has matured a lot. And as we can see, it is used to orchestrate notebooks, pipelines, queries and more. So we will be using this job part. So after click of it, a new job has been created. And here we can specify the name of the job. So as our name of the bank, we will call it as Neo Bank. Then we will call it as source to silver, because source to bronze to silver, we will be creating a single reusable pipeline. So this is the name I am giving. Now we need to create a task, and as a task we need to run a notebook. So I'm clicking this run notebook task. Here we need to give the name of the task. So we will be naming it as like get list of tables. So here we will be getting that list using that notebook. So task type will be a notebook because we are calling the notebook. Source will be workspace only, and we can use a GitHub as well, so that like if we want to maintain the code version and all. For now we will select workspace only. Then in the path we need to select that notebook. So we need to go to the path wherever our notebook is there. So I have stored it here. Let me go there. And after that, this is the banking project, source to silver. So this read table list, this is the notebook I am going to call here. So it is selected now, and now I will click on this create task. And next what we need to do is, as we saw there, it takes a parameter as well. So this is where we are going to create a parameter. So I will click on this edit parameter, and the name of the parameter was source system. So this name has to be exactly same of our notebook widget, like source underscore system. Here also it has to be exactly same, then only it will work, otherwise the value will not be passed. And for a default value, as we are testing SQL Server here, so we will give it SQL Server currently, and I'm going to save it. And there are some other options also here that we shall be aware, that here it is the retries. So by default, if this task failed due to any reason, it will try 3 times by default. We can change it if we want, but normally we keep it. And then job parameter, we already used it. And then there is this concurrency also, like if we run it multiple instances of the same task, then how many instances shall be running. So maximum concurrent, so we will be running like one for SQL Server, one for blob storage. So we can set it to 2, or we can set it any greater value also if we want, it doesn't matter. So we need to increase it so that things can run in parallel. If we don't increase it, it will be running in a queue. And it is saying like this is where the queuing is enabled or disabled. So here we will leave the default value. If we disable it, then like if resources are not available, the job can fail. So we will leave it currently. And then now our first task, it is ready. So now let's run it from the job, and let's understand how our notebook will run and how we will get the output as a task output here. So as we see the pop-up, it was triggered. And if we go to this runs section here, it will show us the runs. Currently, we can see that it is running. If I click this, it will take me to that notebook run page. And here we can see that it is currently running, and it is complete. Run is complete, it is saying. And we can see it has executed successfully. The output JSON we can see here, but this is just the print message output that we had seen. The actual output of the task, it will be shown here, like task values, what values we had set up there. And if we click on this eye icon, this is where it will show. So this is the output JSON of this task that we are going to use in our next task, so that we can go over table by table and then ingest them. So this is how we can see the output value of the task. We can copy from here and put it in a notebook or something if we want to check some more detail. But now our first initial draft job is ready, and it is working as expected. And once we have the list of table available, next what we are going to do is we are going to read the parameters for that particular table. And for that, I have a separate notebook, read table parameters. So let's understand this one. So this table, as we can see, it takes a single parameter named as table underscore metadata. And as we can see, it is taking a JSON entry here, which looks big, but it is pretty simple. So what it does is, if I copy the output of our previous task from here, let me copy from here so that I can explain. And if I see, so these are the table by table detail we are sending. And this JSON for one table, this I'm naming it as table metadata. And this is what we will be passing as input to the next stage so that it can use that. So I have copied that value. Let me remove it and paste the value that I had copied from there. Now this is some default value I have put here for my testing only. We can ignore that. So it is just reading the metadata that was there. If it is not passed, it will throw an error. And by default, we will get it as JSON string. And then to convert that string, first we are converting it as a dictionary so that we can run the get function and get any value that we want. And currently in this notebook, we are only interested in the table ID. So we are getting the table ID. If it doesn't find it, it will throw an error. And then it is casting to an integer because by default it will be string. And then this table ID we will use to fetch our data from table parameters table. So here we are reading the spark.table, our parameters table. From there we are applying a filter where table ID is this table ID, in this case 1. And that table ID, the parameters for that table will be read here. Then from the output, we only need the param name and parameter value. Other columns like table ID and created date, those we can ignore. We are collecting them. Then similar to previous notebook, we are converting it as a dictionary. And that dictionary, we are passing it as a table parameters output task value. So here again, we are setting it up as like dbutils job task values so that we can use it in our next notebook. So now let me run it and let me show how we are getting the table parameters. So this is how we are getting it. So this was the table metadata passed. It was a print statement. So this table was customers table. And then these are the parameters returned, like what is load type, what is primary key, customer ID, watermark column is updated 8. So these are the parameters we have read. So now let's first let's understand the next notebook as well, so that like we will then be able to combine it in a job in one go. So now as we have the table metadata and table parameters, then we are ready to ingest our data. So let's go to the source to branch, which will be the very interesting notebook, and how we can ingest all the tables using a single notebook. So this is the notebook that will be ingesting the data from source to branch layer. As we can see here, this notebook, it takes table metadata as input, which is our customers table, that same metadata. Table parameters, these are the parameters which we get output of the previous notebook, like the same parameter that this notebook is returning. So we will add it here. Sorry. Yes, this notebook. So let me delete and paste it. And then also it takes a run ID. And why we need run IDs is for auditing purpose. So in our run table, we will add this run ID so that we can use it later on for email notification. So this is a default value. We can give something simple also like 1, 2, 3. And during runtime, we will pass it through our Databricks job. Now let's understand the coding part. So the first part, it is the widget only. These are some default values I'm taking. We are just creating parameters out of these widgets and reading these. After that, the table metadata that is there, that is currently available as a JSON. Then we create it as a dictionary. And from that dictionary, we are reading it into separate variables so that we can use them accordingly, like table name, source system, source schema, all these. Here we are building the full name of our bronze table, which is banking.the bronze schema, which will be dynamic. Its value is bronze only. And then the table name, which is customer. So that name we are creating here. Let's run these cells one by one so that we can understand these. So here we can see these are our input parameters that we have received. And this is the bronze table, which will get created after we run this. Here it will be making a metadata entry, and This is for auditing purpose. So we had created this table pipeline runs, and here first it is checking if there is already an entry there or not for the given same table ID and same run ID. If it is there, then it will update. In our case, the entry is not there, so it will create a new entry there. It will insert it like a run ID, table ID, layer is silver, and then this is the time when the job is started, like this notebook got started. This start time variable we are creating above here. So this will be taken as our start time. Then end time we will keep it as null. Status will be in progress, and number of records here it will be null. This one we will be updating after the completion into silver layer. So here we are making an entry saying that it is started, and after the ending of silver layer we will update it again saying that it is completed. That's how it works. And why we are checking? Because entry is already there. This is due to retry thing. So let's assume that bronze, this source to bronze notebook, it fails due to some reason. So if it has any entry already there, so during retry in our job that we will create, that time it will not create duplicate entry. So that is the reason we are updating it if it is already there. So now let's run it so that it will create our metadata entry. The job, it is complete now. So now let's check out our metadata and see what entry it has made into our audit table. So this is the table, and previously it was empty. Now we can see that it has made that one entry. This is the run ID we had hard coded, the table ID, layer, start time, end time is null, state is in progress. Now moving on, let me close these additional ones. Yes. So next what it is going to do is, uh, first it will check like does it have a watermark value or not. So if our load strategy is append or merge, then only like we have watermark value. If it is full load, we don't have a watermark. So load type it, if it is any one of these, then it will read our table watermarks table based on the table ID, and it will pick up that watermark value from here. So that like using this watermark, it can perform incremental load. So it is just reading this and storing it into a variable here. So let's run this one as well. And next, what it is going to do is it will create the bronze schema if it is not there already. So before creating it, let's check it out first. So if we go here, we can see that this is the catalog that was created, and metadata schema was created where we had all the tables, these 4 tables which are there, and the source which we will be using for blob. But currently there is no schema for bronze. So now let's run this cell so that it will create that schema. Now it is executed, and now we shall be able to see a blank schema here. So I'm refreshing it from the top, and as we can see, the bronze schema it is created, and currently there is no table here. Now let's go back, and this here comes the reading part, which is very important. So let's understand it one by one. First, we are checking if it is source system is SQL Server or blob. Because the same notebook we will use for both SQL Server and blob so that it is reusable. If it is SQL Server, which in current execution it will fetch our secret scope details. So this is how it is linked. The string that we had stored there during our secret scope, this one setup secret scope notebook, that we will read here so that we don't have to pass the credentials as hard coded. This is the standard production way of passing the secret securely. So here we are reading that secret scope and that secret that we had passed there. And after that, we are creating a config out of it. And then we are building the JDBC URL from this. So this is the standard part. Then we are passing the host name, port, the database name, And then in the JDBC properties, we are passing the username, password, and the driver name. So this is just the configurations that we are creating here. Then it is building the SQL query that it is going to run. So if it is a full load, the SQL query will be simple. It is select star from the source schema dot source table. And if it is not full load, if it is append or merge type of load, then it need to bring only incremental data. And for that purpose, it is additionally adding this where clause, where the watermark column, the name of the column which we fetched dynamically from our parameters table, shall be greater than the last watermark which we read from our watermarks table. So using this condition, it will be able to bring in incremental data. So here it is just building this query as a variable, and this is where actually it is reading the data. So this is the standard PySpark function like spark.read.jdbc function, which will read the data, and it is taking the URL and the query that we are going to run and the JDBC properties. And finally, it will return the data frame with the source data that is there. And this next part, it is for blob. This one we will cover after we complete the SQL part. And if it is anything else, then it will raise an error. And after that, it has read the data. It will add an insert timestamp column to it with current timestamp, so that whenever we will insert into target table, we will be able to see when the record was inserted for the auditing purpose. After that, here comes the writing part. So if the source system is blob, it will be written in a different way using autoloader. And else means SQL Server. So here it is writing it as that data frame dot write. Format is delta. Mode is append here. So if you notice in bronze layer, we will be using the mode as append always. And how it will work out is in bronze, always it will be append mode. And while writing into silver, we will read this new data that is written. And there we will perform the actual merge operation, so that like bronze, it will maintain the historical data, what data is coming for each and every day. And silver, it will be the exact copy of source at any given point in time. So that is how the standard like medallion architecture works. So bronze has raw data, silver has complete refined merged data, which is copy of the source. So that is the reason in bronze we are always appending the data, and then we are saving it as a table. And after writing it, here we are just counting the number of records so that we can put it into our audit table. And if there is any exception, if there is any failure, right? So then what will happen is that time it will make an entry into our audit table as failure, saying that the status is failed. So first it will get the error message and current time is end time. And then it will update that same record for the same table, saying that the ingestion has been failed. And here I see that previously I missed the condition of the run ID as well, which is very important. So let me add that as well, this one. Because otherwise what it will do is if anything fails, it will update the status of all the entries for that table as failed. But we want only the current entry to be marked as fail in case something fails. And if it is successful, then you will notice that we are not making any entry here. That entry will be made after we load the silver layer. Then only we say that our ingestion is successful. So now let's run this cell and hopefully it will insert our data into bronze layer. And here we can see that exception happened. And this is some problem with our SQL server. So what happens is like if we run it after some time, so for the first time, it will say that it is not currently available. So if I run it again, then it works. So then like probably at the source side, it is spinning up or something. So after retry, it will work. And that is why like I made our process of safe also in terms of like making entries into audit table, so that during retry it doesn't make duplicate entries. And this time we can see that it was successful. So now let's check out our data. If we go here and if we refresh this schema, here we can see that customers table has been created in bronze layer, and these are the columns which are there. Let's check out some sample data. And here I will have to start the warehouse. Let's start that. So here we can see the sample data which has been inserted here. So these are different customers whose data has been inserted. So this is how like this notebook code works. And in the current example, we just saw ingesting one table here, but we need to use it through our metadata driven pipeline. So we will go back to our job and we will enhance it so that it passes all the parameters properly and then ingest the data using these parameters. But before doing that, first we will understand the bronze to silver part as well, so that then it will become end to end. So this same table, as it is inserted into bronze already, so we will insert it into silver layer using this notebook. So now let's check out our silver code. And here also we can see that it is taking same parameters. So run ID has to be exactly same. So I'm passing 1, 2, 3 here. This table metadata, I see that I had already pasted previously, but if you are trying, you can paste it if you don't see. So now let's understand this code. And as you can assume, so this is also reusable code for all our notebooks, or sorry, all our tables for both SQL Server and Blob. The same notebook will be used. And here we are capturing a variable status so that we can do exception handling. I will explain later on. Error message, by default it is blank. Records are 0 by default, some initialization only. After that, these are some widgets. We are just getting the values. After getting the values, we are assigning them into their individual variables like we already saw previously. Now let me run this notebook. It is already run now. And next, this is where the try catch part comes into picture. So in the try part, what we are doing here, we are reading the bronze layer, and from the bronze layer, here again, first we need to decide whether it is incremental load or full load. So it is checking the load type, and if it is here, it is reading that watermark value if it is already there. And if watermark value is there, then it is applying the filter on the bronze table to pick up only incremental data. And then here it is just capturing record count and printing that. After that, here it is adding two columns here, like insert timestamp and update timestamp, so that we can know when the record is inserted and when it is updated. So in silver layer, it can be updated as well. In bronze, it was already append, so it was only like inserted. After that, first we are creating the schema, silver schema, if it is not already there, like currently we don't have. And then if the table it is not there already, so here it is checking, and if table is not there, that means it will create the table and it can simply like use the overwrite mode here. And if the table is already there, then it means like it need to check the load type. If it is full load, it will use the mode as overwrite, so that every time it will overwrite the data, like we have branches table in our case. And in append mode, it will append the data, like we have transactions and one other table. And in merge mode, it is going to merge the data. And to merge the data, if primary key is not there, we can't do merging, so it will throw an exception. And first it is creating an instance of the silver table, then it is creating a merge condition. So merge condition will be based on the primary key, like the target table which is silver dot primary key equal to source which is bronze dot primary key. And here it is performing that merge based on that merge condition. If these keys are already there in the target, it will update those records. If those are not there, it will insert those records. That is how this merge condition works. And finally, here it is storing like how many records are written into target table. And if there is any error, so other than, and if we are using any other load type, it will raise an exception. And after our load is complete, so then if our load type was incremental load like append or merge, then we need to update our watermark value also. So that is what we are doing here. So here from our bronze table, we are getting the maximum value of that watermark column value. And then our watermark table, here we are using merge statement, so that if entry is not there, it will make a new entry. If entry is already there, then it will update that entry for that given table ID. So we are simply updating that watermark value here. And during this silver ingestion, if any exception happens, then status will be mentioned as failed. Error message will be there. It will print it and it will raise it. And there is a finally block also. So whether the notebook is successful or failed, it will always make an audit entry. So as we know, like during bronze layer, we already had made an entry. So this time it will be simple update statement because there won't be need of insert statement. The record is already there. So that same record for the given table ID and run ID, it will update. So other details were already there. That's the reason we are just updating the end time here, which is the current time. Then the status is success or failure, depending on the exception. Number of records we are updating, and error message. If it is not there, it is null. If it had failed, then it will put an error message also into that table. So that is how it is updating it. So this is the explanation of the code. So now let's go ahead and run it for our existing table here. And we can see it is started. It is processing 4,000 records, which is our historical data. Silver load, it is completed now. And audit record is also inserted. So that's great. So our one ingestion from source till silver, it is complete now. So let's go ahead and check out the table first. So if we refresh here, we will see the silver schema also created here. So yes, here it is. And here is our silver table. And we can see that it has both insert and update timestamps. Let's check out sample data as well. And here we can see the data. So everything is inserted. Now let's check out our metadata table as well, so that we can see that the audit entry, is it made properly or not. So where is the notebook? I think I closed it. Let me open it again. And here, this is the table we are looking for. So let's run it. And here we can see that now it has updated that same row. It has updated the end time, status as success, records also it has updated. There was no error. So that is how the ingestion works end to end for one table. Next, we are going to add these notebooks to our Databricks job and trigger from there for all the SQL Server tables in one go. So let's go to our Databricks job that we had previously created. And here this process, it cannot be done using a single job. There is a limitation. First, let's talk about that, and then we will see how we can overcome that. So our output of this task, as we saw, it is we are getting the list of tables. And uh, once we have list of table, we would want to do the ingestion for each of the table. For that one, we have this activity called as for each. And in this for each, we can add a task inside it. So here, first let me give it a dummy name so that I can explain. And inside this for each loop, we need to uh, add like any task. For this input part, first let me take some dummy thing again, because first I'm explaining the limitation which is there. So here inside this loop, we can call a notebook and then it will work. But in our case, what we need to do is we need to call three notebooks. After we get the list of table, then we need to call these 1, 2, 3 notebooks one by one. This one, it will get the list of parameters. Then this one, it will ingest the data from source to bronze. And this one, it will ingest to silver layer. So as we need to call these 3 notebooks, so putting them inside this single task, it is not possible because we need to put them inside this for each loop. So the workaround for that is that those 3 notebooks, we put them into a separate Databricks job itself, and then that job we call it here. Then it will work out. So first let's call that another uh, Databricks job, which will call just those 3 notebooks with the right parameters. So let's go ahead and create another job here. And this one we are going to name it as like source to silver inner job. The job is created. First of all, let me give it the name. And as I was explaining, here we will be calling 3 notebooks one by one. So first of all, it will get the list of parameters. And here we will call the notebook for that. It is inside this folder here. That's all. First task, it is ready now. And because this process we will be doing it for one table at a time, so here also we will need to add the job related parameters which will be passed to these tasks, all the tasks. And the parameters we are going to pass, so one is run id, which will be used for auditing. Another one, it is table metadata. So this table metadata will be read from our get list of tables and then return to this particular job here. So now these 2 parameters, these will be automatically passed to whatever task we create within this job. So this first task, it is ready. Let's add our second task, which will be source to bronze ingestion. Let's select the notebook here. That's it. This task is also ready. Now let's add our final task, which is bronze to silver. And let's call our notebook. And let's create it. Now there is only one last thing we need to do with this job. That is adding the output of this get list of parameters to both of these tasks, so that the notebooks, they can use the parameters which are being read by this notebook. So first let's add in this one. For that we need to go here and then add a new parameter. And the key part, it will be key and value. So let's check out their exact detail here. So key will be this, so that the same names are used. So this is the name, and value part, it will be the output of this particular task. So we click here, it will show us automatically. So get list of parameters dot output dot value. And in the value, so the output name, that is something like here, whatever output it is returning, so this is the name we need to pass there. So this way it will be able to pass the output from this task as input to this task and the notebook. And let me copy this entire thing, so that the same thing we will pass in the next task as well, because this one also it need parameters to work. So here the value part, it will be same, and key part is also table parameters only. So that's it. So now this task, it is ready. And also we need to change one more thing here. So here also there is concurrency. So every job has a concurrency, how much parallelism we can use. So currently it is 1. This also let's increase to 4, so that when the outer loop it trigger these jobs, so all can run in parallel. Now finally this job it is ready, and now we are going to add this job to our outer job in the for loop, so that it can trigger all these 3 notebooks one by one. So let's go back to our outer job, and here also, so let's add that task, the task I was talking previously. So that will be our for each task. Task name will be like ingest data from source to silver. The values, these will be the output of previous task, and that output, what value we shall provide. So this will be the output of this read table list. So let's get the exact name from there. So this is the key which was there. Okay, so now let's add a task to loop over. So now this is that inside task. So that is why automatically it is adding iteration here, so that it will do one by one. And this time it will not be a notebook, it will be a run job, because we will be calling our inner job here that we had created. And source system, this source system, it is being pushed down automatically. And this job, it is also expecting run ID and table metadata details as well. So table metadata, we know we want to pass it as the output of previous job. So here, this is a property of this for each task or for loop, that in if I click here outside, it is passing the inputs, like all the tables metadata array that we were getting, it is passing here. If I click this inside task, then here if we mention the keyword as input only, I click this, I select this input, it is saying like the array value of the for each input. So if we just mention input this way, it will automatically pass the table metadata one by one. And the run ID also we need to parameterize. So currently we have only one parameter. So let's add another parameter, run ID. And its default values, let me give it, let's say 1, 2, 3, 4 this time. And if we see it here, okay, looks like it is hidden here. Let me bring up again. And if we see here, so the run ID, like it will be overwritten, whatever it is saying pushed down, that means this value will be pushed down. And then the source system, this SQL server will be pushed down. Table metadata, it will get it dynamically at the runtime. That is how like these things will work out. And why I'm putting this run ID here hard coded is that even this pipeline also later on we will call it from another pipeline or job. So what we will do is we will create a master job that will first ingest the data for SQL Server, then for blob storage, then it will ingest the gold layer data as well, and then it will send an email. So that kind of master pipeline or job also we will create, and from there we will be passing this run ID. So now our job it is ready, and if we pass this SQL server, it shall be able to ingest all our 4 tables. So let's check it out. Let's trigger it. So I'm clicking this run now option here. and the run it has started. Either we can click here, or if we go to runs, here also we will see it. So it will appear here after a couple of seconds. Okay, now we can see here. Let's go inside this. Currently, it is reading the list of tables based on that SQL Server. So this we already saw. Let it complete and then we will check out its output. So we can see the code is currently running. Now it is successful, and the task values we can see here that it is providing the list of all the 4 tables to us. Now let's go back, and here we can see that it is running our for loop now. And here currently we can see that even though it has fetched 4 tables, currently it is running 1. That is the reason because we forgot to change the concurrency. So the default concurrency on for loop is 1. So by default it will be ingesting 1 table at a time. And currently it is ingesting customers tables that we had already ingested as well. So anyway, let it run, and at least like we will come to know if our code is working fine or not. So let's go inside this. And here we can see the first notebook, it is complete. Let's check out our parameters. So we can see the parameters, it has returned properly. Now let's go back. And currently, like source to bronze ingestion, it is going on. And we can see the first attempt it has failed. And as I was telling previously also, in SQL Server it is a common problem that it may not be available sometime. So it is doing the retry by default as another run, and hopefully this time it will succeed. And how many retries it can do, that is also something we can configure. So we will check this concurrency and retry settings also once this job is complete. And now we can see it is succeeded. So that means ingestion for this table, it is completed. Now let's go back. And now the silver part, it is starting. And looks like silver also, it is completed now. So, and we can see records to process, it is 0 because we had already ingested this table and we did not insert any new incremental data. That is the reason it is returning 0 records. But process wise, this code is working fine. And after ingesting the first table, now it will start the second table. So after customers, we can see that accounts table is being run now. And this table we had not ingested previously. So like this, it will ingest all the tables one by one. So we will let this run go on, and let's check out the settings I was talking about. So let me go to the task here. And if I click this for loop here, and if I go below, so here we can see the concurrency. By default, it is blank. It will do one by one only. So we can change it to any number as well. So in our case, maximum it is 4 tables. So let's put it 5 or something. Oh, it is saying it shall be between 1 and 4. Looks like it allows only 4 maximum. So we will do it. And next time, whenever we will trigger, it will trigger all the 4 in one go. So this is the concurrency option. And about the retry option that the bronze task was doing, or any task that we will do. So let's go inside that job. Now let's go to the tasks here. And if I select any of these tasks, and if we go to the retry count, so retries, it is saying like immediately it will do after failure, and at most it will do like 3 retries. So one, like 3 retries mean 4 total attempts. So these are the default value it provides. This is also like good enough, but if we want to change it from here, we can change it. If we want no retries, or how many retries we want. Between retries, if we want to wait for couple of seconds, minutes, or hours is not practical, but all these settings we can customize. Now let's go back to our main pipeline and see how many tables are completed. Looks like it is successful, and we can see that all the four jobs has been run successfully. If we go inside, we can see for each of the job, like the table name here, the status here. So everything is successful. Now let's check out our metadata and let's confirm that the audit entries are there. So here we can see all our entries. So this time we had given the run ID as 1, 2, 3, 4. So four tables has been ingested. Layer is silver. Start time and end times are also updated. Status, it is also updated here. And we can see number of records as well. It has been updated. And this zero record, it is for this customers table, which we had already ingested. So there is no new data in that one. And the entries looks really good. Now let's confirm if our tables are also created. So this is our bronze catalog, and let me refresh it so that we can see the new tables. And here we can see our four tables has been created, and let's check out any of that table if data is there. The table is there. Let's check out some sample data. We can see the data here like account ID, customer ID, it is being populated properly. This was bronze layer, and let's have a look at our silver layer as well. And here also we can see all the four tables has been created. This time let's check the transactions table. And here also we can see the proper data which is loaded. So now we are all good with the historical data for SQL Server. Next, we are going to load the data from blob storage. So let's set up that source. To set up the blob storage as a source, we are going to use volume in Databricks. So in this source schema, the volume is already created for us. And this was created as part of our metadata setup. So if I go there, in our metadata setup, we had created this schema and a volume here. And volume currently it is blank, and volumes they act as a directory and folder structure where we can store files in raw form. And in this project, we are going to use this Databricks volume. But in practical, we can map any Azure blob storage as a volume in Databricks. And after mapping, rest of the things is same. So this will behave exactly how a blob storage will behave. So currently this volume is blank. We are going to create a folder here for both of our tables that we are going to ingest, and then put CSV files there. So first let's create a folder. So let me copy the name of our tables there. And these are the names we are going to use, like credit bureau reports. So with this name, let me create a folder. And the second folder will be this one, payment gateway logs. So let me create another directory here. Oh, this is inside that. Let me go back outside. So previous directory is created, and now this will be another directory. So now assume that in these two locations, the files will be uploaded from the source teams as a blob storage. So whenever they will upload files, this is where we will get them. So first of all, let me upload some historical data, and this is the sample data I have included in the repo. You will be able to use it. So these two files are for historical load, and then these two are for incremental load. So first let's put our historical load files here, and simply we can upload them. The files will be put up there. Let me refresh it. We can see the file is uploaded. Similarly, let's upload the second file as well. Let me go there, and this file we can directly drag as well without clicking on upload. So let me upload here. This is also uploaded. So now both the files are uploaded and we will need to run our pipeline. But before running it, first let's understand the code and see how exactly it will work out. And by now you know that these two notebooks will work exactly same. Like for Blob also, it will read the list of table, the two table entries that we have made here. Then it will read parameters for these two table from parameters table in the exact same way. The difference, it will come in the source to bronze notebook. So let's check it out. And for this also, the parameters and all will remain same. Let's go to the place directly where we are reading those files. So here we are reading the SQL Server, and then in the else part we are reading the blob part. And here we are using autoloader. To use autoloader, we use this function like spark.readStream. And when we specify cloud files, it means we are using autoloader for that. And here format is CSV. We are specifying that. And schema location also we need to specify in autoloader. And if you see the schema location, I have specified in the same volume where were uploading the file. So there it will create a directory with underscore schema, then with the table name, and store the schema there. We don't need to put any schema our side there. It is that this autoloader, it internally manages schemas of the data that it is ingesting. So that is what it will store there automatically. And in our CSV files, header is there. So that's why header is true. So this is how we will be reading those files. And then on the writing part, uh, this is how we write the data using autoloader. So the same data frame we have created above with this additional column. Then format will be delta only. And we need to specify a checkpoint location as well, which is very important. At this location, it will store its progress, which all files it has processed, so that next time automatically it can pick up new files. So that way, like autoloader works, it keeps a track here which all files it has already loaded. And then the output mode is append, because in the bronze layer we always append new data. And in autoloader there are different types of trigger available now true. What it means is like process all the new files whichever are available and then exit the code. And then there are other modes as well, like one is continuous, which continuously run, so the job never completes, it will continuously run, keep loading all the files. We don't need a streaming kind of use case here. That's why we are using this. And finally we are writing the data to our bronze table. So this is the only core difference between SQL Server and blob storage. Now let's go ahead and run our pipeline for blob. And for that, you may have guessed by now. So what we need to do is we will use our exact same pipeline. We will just modify the parameter value like blob. And this time this run ID for testing, let's give it until 5. And that's it. The same pipeline will work for blob storage as well. So let's go ahead and trigger it. It is running. Let's check it out. It is currently fetching list of tables. Our list is ready. Let's see which tables it pulled. Here we can see the output. We can see it has fetched those two tables only. The source path is also correct. This is where we had put up our CSV files. And if we go back, let's go inside here. And this time we can see both the tables are running parallelly. So it is not queued or something. And if we click any one, it will take us for that particular table ingestion job. For this one, it has fetched the parameters. Currently bronze load it is trying to do. Bronze is successful now. Now silver will start. And silver there is no change, so it shall go through easily. Silver is also complete. Now let's go back. We can see both the tables are successful. So this worked well. Now let's check out our metadata entries first. Let's check our audit entries here. And we can see those two entries has been made here. Status is successful. This many records has been ingested. So we are all good. Now let's quickly check out our tables as well if those are created properly. First, let's check in bronze. Yes, tables are there. Let's check out some sample data. So this is the kind of data we are getting from credit bureau. Like for each customer, what is the credit score? What is the risk grade for that? How many loans are active? All these details we are getting. And let's check out the silver layer as well. And this time, let's check out the payment gateway logs. Here also we can see the data. Here we can see which gateway was used to make any particular transaction, whether it was bill desk, Razorpay, Strip, all these things, and transaction status, device type that was used. All this information we are getting from this particular table. And here, if you notice, there is a column automatically added with the name underscore rescued data. This is something we did not add from our side, but this is what autoloader is doing. So autoloader, it has a built-in functionality to rescue any corrupted data. So in future, if any column comes, any row in the data comes where the data type it is not matching, or if it is not fitting into these columns properly, some invalid value is coming and all. So for those entries, it will put those rows in the rescued data. That is why automatically it adds it as a new column, which is really nice. Now, finally, we are done with our silver layer historical load. And next layer we are going to work on is the gold layer. So let's see what is there for in the gold layer for us. So in gold layer, you will notice that there are two sections I have created, some notebooks, and then there is a reusable driver notebook. So how I have like modularized this part as well is, so the specific logic that is there, that will be the inside the notebook, the transformation logic, and to orchestrate these notebook and put entries into our logged our audit table, that is where we will use this outer notebook. So this is again also will be metadata driven. So first let's check out these gold tables one by one. First one, it is about branch performance. So as we know, like we have data related to customer branches and all. So in this in this gold table, we are going to aggregate the details related to branch and then prepare a summary so that we can show it in the dashboard. So for that, from the customers table, we are getting the customer ID and branch code. Then from the accounts table, we are for each customer, we are checking how many total accounts are there, how much is the total balance for the customer. And then we are joining the transaction and accounts table here, so that like we can get the aggregated data, how many total transactions has been made, and what is the total sum of the transaction that has been made. And then finally we will join all these. So we will join the branch details, account details, and transaction details, and then we will prepare a aggregated detail like this. So finally we will have data like branch code, branch name, how many total customers are there in the branch, how much is the total, how many total accounts are there, what is the total deposit amount there, how many transactions customers are doing there, and how much is the amount of transaction there. So this data we will get in our gold table. And after the transformation, so we have this as a like audit part. So what we are doing here is that because we are entering the record count into our audit table, so we are simply getting a count star from this table, and then we will be returning it. And this time, instead of setting it as a task value, we are using the exit function. And why we are using it? Because this notebook we will not be calling it from the task directly, we will be calling from this outer notebook, and this notebook will receive this count and add into the audit table. So we will see all that in more detail, but basically that is the purpose of this part. And to test this notebook, we can run it as standalone as well. And as you can see, it is create or replace table. So if this table is not there, it will simply create it again. So let's go ahead and run it. And looks like it failed. Let's check out the error. It is saying like the schema gold, it is not found. Oh, okay. So this gold schema by default, it is not there. I had put up it in the driver notebook, but as we are running manually, we didn't get it. So here is the statement. Let me run it manually from here. Now our gold schema is created. Now let's go back to our branch performance table and run it again. And this time it is successful as expected. And we can see that the output number of records are 4, because currently in our bank there are only 4 branches, as this is like a demo project. So this notebook, it is ready. Next, let me explain about customer 360, what data we are preparing there. So this time, we from the accounts table, we are getting for each customer, like how many total accounts are there, how much is total balance. And the overall intention of this notebook is to focus on customer related aggregated information, so that we can show customer related insights. Next, what we are doing here is that we are joining the transaction and account table to get the total transaction and the total transaction amount. And then here, like we are fetching the latest data for the customer for the given day, like based on the pull date. So in the like a bureau report, so as this is incremental data, so for same customer, if we are getting the data multiple times, so latest data we are picking up here. And then finally we are joining all these tables which we have prepared above. And then we are aggregations were already done above. We are adding some coalesce, that if the total balance is not there, show it as 0, like that. This coalesce statement will work. It is like if else. If this value is there, take that value, otherwise take it as 0 if this thing is null. So, and here we are preparing a customer segment as well. So if the total balance of the customer, it is greater than this value, then that customer is a high value. And if it is greater than this, then the customer is medium value. And otherwise the customer is low value, so that we can know what are the top customers with high value, and then we can contact them or something. And that's it. So let's run this notebook also, so that our goal table is ready. This is also completed, and we can see that this has 4,000 records. So that means we have 4,000 customers. So now before going to other notebooks, let's quickly check out these tables also, whether these are created properly. So here we are. Let's expand the gold schema we have. So if we check out the branch performance, we can see these are the 4 branches we have, and the data, it is populated properly. And if we go to customer 360, here also we can see that the data has been loaded properly. So we are good with these 2 tables. Now let's go to the next table that we have, that is daily bank KPI. So this will, the focus of this notebook is to prepare some KPIs related to bank, like as a bank overall how many transaction it is doing on daily basis and all. So that is where in the transaction, from the transaction table, we are this time we are doing group by the date of the transaction, so that day wise we can analyze the data. Then we are getting the number of transaction and the total amount of transaction. Then from customers, we are simply getting how many total customers are there. And then from accounts, we are getting how many total accounts are there, how much is total balance as a bank. And then from this credit bureau report, we are getting the average credit score that we have for all our customers. And then like how many high risk customers are there, so that like we know if we have some higher risk overall. And then Finally, we join all these tables and prepare our final table. So let's go ahead and run this notebook also. The execution, it is complete now. And this table, we have 396 records. Let's go to the next one. This one is a small one. As the heading says, it is like a risk customer summary. So here, what we are doing is based on the reports we are getting from credit bureaus, we are doing a group by based on the risk grade, so that for each risk grade we may know like how many customers are there, what is their average credit score, and how many loan amounts are there, like that. So that info we are preparing. So let me run this one as well. This was a quick one. It has just three records because there are three different risk grades. The data we will understand later in more detail. And next one, it is about a transaction channel summary. So in this one, as we are getting the details from the payment gateway, so from there we are preparing a summary. So what we are doing here is that we are joining our transaction and payment gateway tables. After that, we are doing it for each of the transaction date, what was the gateway name and the device type that were used. And then for that grouping, we are calculating the total transactions, how many successful failed transactions were there, and what was the average processing time. So all this information we are gathering. So let me run this notebook as well. So with this, all the notebook execution would be complete. And next, what we are going to understand is how we are going to orchestrate these notebooks through our pipelines. So for that, the driver notebook comes into picture, and this notebook will be able to trigger whatever notebook we want to. So this notebook, similar to a silver notebook, it is taking run id and table metadata, same way we will pass here as well. This time there is no table parameters because gold tables, most of the time those are always full load because joining of multiple tables is there. So that's the reason we don't need any parameters there. So in this notebook, it is taking our table metadata. If it is not passed, it will throw an exception. Then it is extracting the variables like table ID and name out of it. Current time it is preparing. And then schema it is creating if it is not there, which we already created manually also. And then this is the part like why we are calling the notebooks through here. The main purpose, it is auditing. So in our audit table, similar to silver layer tables, it will make an entry. First, it is checking whether there is already an entry for the given run ID and table ID. And if the entry is already there, it will update the entry. If the entry is not there, it will make a new entry. After making this audit entry, this is where it will prepare the notebook path dynamically. So depending on the table name, the corresponding notebook it will pick up from here, and then that notebook it will call in the next cell. And here for the exception handling part, the similarly we are preparing these variables, and then this is the function we are using to call the table specific notebook, which is dbutils notebook.run. And here we are passing the path. Timeout 0 means like there is no timeout. It can take whatever time it want. In production, we shall set it to some maximum time that we are expecting. And as a result, so the each of the notebook, if we noticed, that was returning the number of records. So when it is exiting, it is providing count as output, and that count we will get it here as a result. And if it is like there, then the records variable will be put up with this value. And if there is any failure, then status will be marked as failed, and error message will be marked here. And this after executing this notebook, next what we are going to make is again the audit entry. So we will pick up the end time and we will update the entry which was made there. And if the status was failed, Then we will raise an exception so that the outer process or the job can know that actually the process has failed, even though we had made a job, even though we have made a audit entry. And if you noticed here, when we were capturing exception, so as we are not raising it, the notebook will not fail here, and it will come here and then fail, like if there is any failure. And one more thing, if you notice, like here we see this as a additional run. So let me run this one of the notebook with this default metadata that I have put here so that we can understand this part. So it is running now. Okay, completed. Now, when it is running this actual notebook based on the table name, so when we use this function dbutils notebook.run, it will trigger it as a job in Databricks, like internal job. We don't need to manage that job or anything, but it will appear that it is working as a separate job. And this job, it is successful now, and at the end it is returning this as a output. So that is how it triggers that, and the output of that job it take into our variable and then use it for the next step. So now this notebook it is executed successfully. So let's confirm if the audit entries are proper. So let's go to our check metadata and let's check the run entry. And here we can see the entry, the run ID, the table ID. So similar entries has been made for this particular table as well. And all this information will be used when we will send that consolidated email at the end. And this is all about gold notebooks. Next, we are going to create a job to orchestrate these gold notebooks. So let's go ahead. Let's go to the job section, and this time instead of creating a job from scratch, we are going to clone our silver job and then update that. So from here, we will directly, we are not getting the option. So we will open it and then clone it. So here we will click this clone job, and this time it will be from silver to gold. So let's clone it. This is our clone job. So parameter wise, it will be same. And here the default parameter, let's change it to silver, because the source system for gold it will be silver. This ID, let me put a 6 here to give a new dummy run ID. And then here there will be no change because we will be reading the list of gold tables from our metadata table only. And the main change it will be here. In silver layer, we were calling it as a run job. We had an inner job which had three steps. But for the gold, we just need to run the notebook. There are no multiple steps there. So instead of creating a inner job there, directly we will call the gold notebook here. So let me select the notebook and let's select our gold notebook. And then let's check out our parameters. So run ID and source system are already there. We also need to pass the table metadata as well. And in the value part, we need to mention the input like we have done, because that will be our table metadata. So let me save this task. So it is done. That's all what we need to do to run all the gold notebooks in one go. So let's go ahead and test it out. So I'm going to click this run now button. The run has started. It is currently fetching the list of tables. And after getting the list, it has successfully run all our notebooks. And as we can see here, it ran 4 notebooks. So I noticed that one metadata entry was missing for this customer summary. So that also I have done here, so that next time whenever we run, all the 5 notebooks are run. So we can see all the four of them are successful, which we ran. And let's check our audit entry as well. Here we can see our audit entry. So the four tables we ran, it is working fine. Entry looks good. So now we are good with all the notebooks and the individual source to silver and gold, silver to gold ingestions. Next, what we are going to do is we are going to build a master pipeline that will first ingest the data for SQL Server, parallelly for blob storage. After both are complete, then it will trigger gold pipeline, and after that it will send a consolidated email as well. So to build that pipeline, the missing part is the email notification. So let's check that out first. So here I have created a notebook to send emails. And this one, it is just taking a run ID. That's all it needs. And the run ID, it will be common for SQL Server, Blob, and Gold, so that it is able to pick up all of the entries in from our audit table and include it in our email part. So it is just taking that as an input. Then it is joining our pipeline runs tables with tables table so that it can get the table name which is not there in our pipeline runs. And then here it is picking only the required columns and some renaming so that it looks better in the email. After that, what it is doing is here it is just checking like how many tables were successful and how many are failed, so that it can prepare a overall status which will be included in the subject. So if all the tables are success, then only it will say success. If any one table fails, the email heading will say failed. And then that in that table which it is reading here, this data frame, so we need to convert it as a HTML table so that it can be included in email, and in the email we can see it is a table. So that is what we are doing here. So this is how the HTML looks like. After that, we are preparing the HTML body of the email. So here, like this is some HTML syntax. So I generated it using like GPT only. So this is pretty easy, but this is the part like how we will get that email that this thing is completed. Here it will include our HTML table, and then it will say like for any queries or something, reach out to this. That's all. That's how the body will look like. So this is how the HTML content looks like, but when we will get the actual email, then it will be better. And here we are preparing a subject. So subject will be something like banking, then the status, whether it is success or fail. Or here I can call it as neo bank, and then it will say this end to end run. And here we are fetching the Gmail API key, or they call it as app password. So this is one configuration we need to do. If we have a Gmail account, getting this key, it is pretty easy. If we simply ask Gemini or any other LLM, it will tell us exactly where we can generate it. It's very simple. After generating it, what we need to do is we will need to put it in our secret part. So wherever we were setting up the secret scope, there I had included the code to put this API key as well. So this is where I have put the code. So this is the key name, and here you need to paste your own API key or the password, whatever we call it. And then within that banking scope only, it will create this as a secret. And this secret we are reading in our send email notebook. So we are just reading that API key, and after that, this is the standard SMTP like protocol or standard way of sending an email. So the important parts are like these, like to which email ID we want to send the email. I'm using my same email ID only, and then where we want to send it, what shall be the subject which we prepared above. The body part also we prepared above as HTML, so it will attach it. And then It is connecting with the SMTP server of Gmail and then sending our email. After that, it will simply say like send email is sent successfully. And to showcase a quick run, so let me put the run ID which we recently used for gold tables, and let me run it. The notebook is successful, the email has been sent. And if I check out my email ID, so this is the email it has sent because all the tables were successful. So this is the status overall. And then this is a text. Here is the table with all the required details which are there. And then just some footer part. So that's how we can get customized generated email very easily. And why we are choosing these custom emails is because here we can see all these details in a really good manner. And within Databricks as well, it provide a functionality to uh, auto generated emails as well. So that part they call it as job notification. So this is also like very easy to configure. If we add any notification here, we need to mention any email ID and whether we want to get the email only on failure or only on start, success, and other options. And we can like mute it for skipped and cancel runs if we want. So this way we can configure, but getting these email, these are not really like that much informative. So for technical user, like they will know what is the error or something on failure, but which notebook is successful, which table is successful, how many records are there, quick summary kind of thing, we can't get using these emails. So that is where these custom emails comes really handy. So now pipeline wise all the pieces are ready. So let's go ahead and build our master pipeline. So here we are going to create a new job and we are going to name it as neobank master pipeline or master job, whatever we want to call it. And then we will be running jobs from here. So I'm clicking this run job. So first job we will be triggering is source to silver for SQL Server. And it will be run job type, and then it will be neobank source to silver. And this one it needs two parameters, run ID and source system. So here run ID, this is where we need to pass it dynamically at runtime. So for from this current job, which will be our master job, from there it will pass the job run ID dynamically. And then source system, if we want to ingest SQL Server, so it is going to be SQL Server. And that's it. So let me create this task. So this will ingest the data for SQL Server. Next, let me clone it and then we will configure it for blob. So the clone it is ready now, and this time job will be same only, and only the parameter this time we will pass blob so that it will pick up the blob related to tables. And after these two are done, then we are going to run our gold pipeline. So again, let me clone it. And this time we will call it as silver to gold. And this time the job will be different. It will be silver to gold job. And here this additional thing we need to change. So if we by default all these three jobs or tasks will start in parallel, but what we want to do is we want to start the gold ingestion only after silver of both blob and SQL Server is completed. So for that purpose we need to configure this depends on part. So this gold part it depends on blob and also SQL Server. So that is how the dependency will work. and we want to run gold. uh, by default it will run only if both are successful, but in our case we can trigger it based on all done. All done means like the execution is completed, whether it is successful or failure, it doesn't matter. There are other options as well, which depending on the scenario we can configure. And why we are selecting all done here is because our gold notebooks are full load. So if any of the silver table fails, then the gold will be refreshed with whatever latest data is available into the table, so it works for us. And after the gold ingestion is complete, next we want to send an email notification. So for email part, we will have to run a notebook, and in this one it will be called as send email, and the notebook we need to select which we had configured. Here is our notebook, and this notebook it takes a uh, run id as a parameter. So let's pass that one. Yeah, for notebook it is not popping up automatically, so we need to pass it this way. And value part we will pass it dynamically like all the other tasks, and that's it, it will be able to send the email. And one thing I forgot, so current by default it is running only after succeeding of gold, but here also we will select all done. So whether it is successful or failure, we want to get the email, so that way it will work. And in our silver to gold, the source system also it shall be silver, not blob. So let me change it. Now our end-to-end pipeline from source to bronze, silver, gold, and then the email, it is ready. So let's go ahead and run it and let's check out how it is working. So here we can see that the jobs for blob and SQL Server has been started, and these two are currently blocked. So once these two are complete, then only gold will start. And here if we click any one of them, it will take us to that particular job, and there we will be able to see at which step it is currently there. So we can see that list of tables it has fetched, and currently it is queued. So it can be queued sometimes in free edition because of the resources which are available. And if we go back, here we can see that blob it is already completed both the tables, and now SQL Server it will be moved out of the queue and then it will start that ingestion. So if we click here, we can see that currently the four tables of SQL Server are running, and their individual status also we can see here. Currently one is queued and three are running. So let's wait for these to complete. So now we can see that source to silver it is complete for both the sources, and currently gold has started. And finally the gold is also completed. Let's go back and check out overall status. So everything it is completed now. And if we go to the email part, so this is the email we have received now end to end. So overall status is successful, and all the tables details we have received here. So these are the tables where the layer was silver. So four from SQL Server and two from blob. Everything is completed, and gold tables are also completed successfully. And if we want here, we can include the source system also as a column simply by selecting the in our email notebook, so that that also we can see which table is from SQL Server and which one from blob. And here we can see number of records also we are getting. Silver part we see that records are mostly zero except one table. This is because we don't have any incremental data currently in those tables. This one was full load, so that's why we are getting data. And to bring in the incremental data, that is where we will work next. So to bring in incremental data, I have included these scripts and SQL CSV files as well. So first we are going to run this SQL query into our SQL DB so that some incremental data it is inserted. So let me open it. I'm going to copy it. Now let's go to our SQL DB. So this is where we run queries. Let me run it. And we can see that data has been inserted successfully. So in SQL Server, our incremental data it is ready now. Next, we are going to put our incremental data into volume part. So here is our volume, and if we see here, we can see that extra folders has been created. So if we go inside checkpoints, we can see that for both the tables, the checkpoints has been created. This is how internally it tracks the progress. And also in the schema part, for both the table, it has stored the schema, whatever it is reading the files. So that is how these two folders are created automatically. And for incremental data, we need to place the new file here. So let me upload that. So this is the incremental file which I have. And we don't need to delete the previous one because using the checkpoint location, automatically it will know which one is the new file and that only it will process. And then let me upload the second one. And that's it. Our incremental data, it is ready in blob storage as well. So next we are going to trigger our end-to-end ingestion again so that the incremental data from both these sources flow in. So here is our master job, the same job which we had triggered previously. So let me trigger it again so that the incremental data, it will flow in from blob storage, from SQL Server, and then gold tables are refreshed with that. And then the same type of email we will get. So let's wait for this run to be completed. If I open it, the same way we can track the progress. So I'm going to pause it until the job is completed. Now the run is completed successfully and we can see that end to end it has completed only in 16 minutes. And if we check out our metadata entries, so let's see if that is coming properly for incremental data. So here is our metadata entries. We can see that run ID, it has been populated dynamically during runtime and all the details are coming properly. Number of records also we can see this time it has been updated for all the tables. And if we go to the email part, so this is the email which we have received, which is similar to full load. And this time the incremental counts are coming for all the tables. So now, as we have understood the complete process of historical data plus incremental data using all the reusable notebooks and framework, so our data it is ready to be served now in gold layer. The next thing which we are going to do is actually serve the data using dashboards and AI/BI Genie. So next, let's go ahead and create a dashboard in Databricks. So for creating a dashboard, we have this dashboard section. Here we need to click on create dashboard. And by default, it is a blank dashboard. And we are going to name it as Neobank dashboard. And first of all, to create anything in the dashboard, we need data. So we will go to the data tab and currently we can see that data sets are blank. Here we can add any table manually, we can upload a file or create it from SQL as well. So in our use case, we will go ahead and create it using SQL. So here, first of all, we will be getting how many customers do we have in total. So if we run this query, now we can see we have 5,000 customers. And here we can give a name to this data set, which will help while creating the visualization. So this is the name of the data set. Next, we are going to create another. This time we are getting how much is the total deposit that we have. And that's all. Let's run this one also. So this much deposit we have. We are very rich, we can see. Now let's create another. And this time we will get total transactions. So these are some simple data sets I'm creating initially. Then we will create like more data sets which include more detailed data. Now let's create another data set here. This time we are counting how many high risk customers do we have. So this many customers are there with the high risk. And before creating further data sets, first let's create a simple visualization so that we understand the process. Then we will go back and create more data sets. So this is the visualization part. Here we click it, we add any visualization. And this is for global filter. We are not going to apply any global filter. Global filter means like whatever data we see. So entire data, it has some filter condition. And from the top bar here we can rename this page. So we are going to name it as executive dashboard. And here we can add multiple pages as well, which we will. First, in this visualization, to add the real visual element, we need to select the type of detail we want to show. So here I'm selecting counter, and first we will be showing the total customers only. And then in the value part, we are saying that we will show here the not the count, like the value of the customer. So how many customers we have. And this visualization, it is ready, but here we don't see what actually it presents. So for that I'm enabling this title, and then we can mention here that this is total customers. Next, let's add another visualization for other items that we had. And this time again let's add a counter. This time we will mention total deposit. Value will be the total deposit we have. And let's add a title as well. And it is ready. And let's align it little bit. So let's show them side by side here. Or as we have more counters, maybe we can use some smaller size here. So now this one is also ready. Let's do the same thing again for another counter. This time total transactions we will show. The same counter type let's use, and the value. And this becomes our total transactions. And now we are left with only one, that is our high risk customers. How many are there? So this is also just a number, so we will show it as a counter. Now let's reduce its size so that it can fit into this single line. So this becomes our basic executive dashboard. So let's say whoever is the owner of the bank, they can see how many customers are there in the total, how much deposit amount they have in the bank, how many transactions has been performed, and how many customers are there with the high risk. And these are very basic visualization, I would say. Next, let's add some more data so that we can create some graphical visualizations. So with this SQL, we are calculating that segment wise how many customers are there. And this one we will call it as customer segment distribution. So this is the data we have. Now let's create another SQL. And this time we will get the risk distribution, or we can call it as credit risk distribution. So we have like customers with high risk, this many, medium, this many, and low, this many. So we have good distribution here. And now let's add another. This time we will see how which ones are our top customers, so that like we can keep an eye on those. So these are our top customers. So these three data sets, they provide insight about the customer related. And as we can see, so the here the color is dark, that means those are actually used in the visualization. These three are new and not yet used. So now let's go ahead and create another page here, and this time we will call it as customer insights. And let's go ahead and add a visualization here. And here we will say that customer segment distribution. And this time we are going to go ahead with the bar chart only. And so here x axis it will show the customer segment, which segment it is. And in the y axis we will show like how many customers are there for that particular segment. So here let's rename the title as well, that this is segment distribution. And here by default we see sum of customers. So if we want to rename that part, so here we can put any name. So this is basically number of customers. That way we can rename these bars as well. This is fine, or this one also if we want, here we can give another name. Now this visualization is ready. Let's add another. And this time we are going to see the credit risk distribution. And instead of a bar chart, we will create a pie chart this time. And here the angle, it will be the risk grade. Sorry, the angle, it will be the number of customers that are there. And color, it will be the risk grade. So now we can see that how many customers are there with each of those. And by default it is showing a distinct count. That is why all of these we see parallel. But what we would need is a sum, so that the total number of customers also we can see. So this is our risk grade distribution. So let's give it a title. And then let's create another visualization for our top customers. So let's add it here. And those customer, because that is kind of a table, so we want to see all the customers. So here we will select a table. And then here we need to select the columns that we want to see in our table. So that is how simply it will showcase our table here. And here we can see these are our top customer, the name, the branch name, and the balance. These we can rearrange as well, so that the name appears first. And then we can give it a title here, like top customers. And that's it. So this visualization, it provides insights into our customers related data. So this is ready. Now let's go ahead and create more visualization. And as we already have customer insights, next we are going to get branch specific insights, so that we can know which branch is doing better, which branch is not doing well. So it is, we can call it as branch deposits. So now we know branch wise how much deposit is there. Next, knowing like how many customers are there in each branch. So that is also important. And that is what we will prepare here. We will call it as branch customers. And finally, we shall also be knowing how many transactions are being performed by each branch. So that we are putting here. So now these data sets are ready. So let's go ahead and create another visualization. This time it will be branch insights, or we can name it as branch performance. And let's go ahead, add this visualization here, and let's select branch deposits. Let's select maybe a pie chart angle. It is going to be the total deposit. Color, it will be the branch name. And this time title and all I'm not putting, so you can put if you want. And there is another option to clone the data set as well. So this time I'm going to clone it, and simply I'm going to select top customers here, and the field, it will be the total customers, and branch wise it will remain same. Now let's add another branch, sorry, another visualization. And this time, instead of creating manually, we are going to create it using AI. And we are going to tell it that show me branch wise transaction amounts. And if I press enter, on the right side, it is going to open the Genie code, and then it will think about it, which data set it is going to use. And it has found the data set, and automatically it has created the visualization for us. Here we can see it. So in total, we have only 5 branches. And if I expand this, then we can see their complete name, how much transaction amount has been there. So this is, I would say, even better. This AI has created like better visualization than we were doing, like separate colors, better alignment, and visualization type also it has decided automatically. So this is how we can use AI. Now, after checking the branch performance, the last piece is gateway related information. So let's build that as well. So here we are going to get like which gateway type, how many successful and failed transactions are there. So let's name it as gateway transactions. And then finally, our final data set. This is going to be about device type. So like which device type is being used for different transactions. So let's add another page for to showcase these. And this time let's try to use AI again. Show me gateway wise transaction success and failures. Let's see how does it show. And here we can see its thought process, what it is thinking about, the table it has identified, and how it can show that as well we can see here. And this time we can see that this transaction status, this is confusing. So sometimes AI can make mistake. We all know that. So let's go ahead and delete it. Let's create our own. So that's what AI can be useful sometime, but sometime it can be tricky. So let's select this time the chart type. We will use bar chart only. X-axis, it will be our gateway name. And then y-axis, it will be the successful transactions and failed transactions also. We can show it together here on top of success only. So this way it looks better. So this is ready now. And so far we have not talked about filters. So let's try to add one filter as well. So from here, we can add a filter, and we can select any value here. So this is like a single value picker, and the field like from which a data set we want to pick up, we can select here. So we will select the gateway transaction, then the name of the gateway. So depending on the selection, it will show the data whatever we select on that filter. That is how filters can work. And we have this text box as well, so these also we can add if we want to add any description or any big text, whatever we want to add we can add here. Let me give it some bigger size here. Like that we can add some text as well. Now let's add another visualization, the final one. Finally, this time we are going to see device wise uh, transactions. So let's select a pie chart. Angle can be total transaction, color can be device type, and we can see that. So this is how we can create all these visualization. And once we are ready with our dashboard, so next thing we need to do is publish it. So let's go ahead and publish this. And by default, like permission, it will use automatically. We can click it to notify the users as well. And we will go ahead and publish. That's it. The dashboard, it is published now. And how the business users, they will see it like this. Let it open. So here we can see they won't see any data set or anything, whatever is there. They will only see the final visualization. And we get this ask Genie part as well, where we can ask anything in the natural language. Before asking here, let's create our own Genie workspace, and then we will see how that works. So now let's go ahead and create our final component, which is going to be a Genie workspace. So I'm going to create a new one here. Here we need to select which all data sets we want to select. So directly from here, it is showing the gold data sets which we will use. But if it is not showing, we can click here in the all, and we can go to our catalog, then schema, and then from here also we can select. We can select one or multiple, but we will select all from here for now, and then click on create. And that's it. Our uh, Genie workspace, it is ready. It has also given it a name automatically. And here we can ask it some questions as well. So let's ask it, let's say, tell me gateway wise transaction success and failure. So if we ask simply that, it is currently understanding our question, finding the right data, it is defining the steps, it has found the related data, it has fetched the data, and we can even see the code that it has run. So if I go here and click on this show code, we can see here the SQL query it has generated. And then finally, it is showing the visualization as well. So this is how Genie helps. So whatever question we have about our bank at a high level, we can simply ask it here. And next, to make this Genie more powerful, we get different settings. So here we can add a description which business users can check it. We can edit it if we want. Similarly, we can add some common question which will showcase to any new user whenever they log in. There it will show. These also we can edit and put any common question. In this data section, the data is already there. We can see we can add more data if we want. And then in the instruction section, which is very important, here we can put some general instructions like what all measures are there and what data to return, what kind of request to deny. Some generic instructions we can provide here as a text, it understands everything. And in the joining condition, we can specify the joining conditions here. For example, let's say customer and branch table if we want to join. So these can be joined using branch name or branch code. So that way we can define it, what type of relationship we want. Even though Genie automatically can also figure out how to join tables if required, but it is better to provide here as a joining condition so that it is not doubtful about that and quickly it can figure out. And in this next section, we can provide some common SQL expression like what all measures are there, some of this price, it shall be called this. Some synonyms we can add, some instructions we can add, so that whatever repetitive information the users are requesting, those it can provide quickly. In the SQL queries, we can add some specific SQL query, like based on any particular question. This is the SQL query that makes sense. So that, like for repetitive ask, it can directly return that SQL query. It doesn't have to think again and again. And then in the monitoring section, we can monitor whatever queries has been run historically. And in the benchmark section, we can add some benchmark like question and its respective answer that we are expecting, so that after adding multiple benchmarks, we can run those benchmarks, we can see how our Genie is doing. So using all these options, we can make Genie like so much powerful and make it return the exact data that we want. And for the business users to use this Genie directly, they can access the Genie from here as well. And recently, Databricks, they have launched this Databricks One UI, which is also very important and friendly for business users. So if you see this, we don't see any clutter here. We don't see all these options, because business users, all they care about is a simplified UI. And here they can only see the dashboards that are there, the Genie workspace that are there. So only those things it can see. And from here, they can access directly whatever dashboard or Genie workspace that we have. And then they can do whatever they want. And then next part comes about scheduling the dashboard, because the dashboard data, it is by default it is refreshed only like once whenever we do it manually. So we have two options. So one option is that from here itself we can schedule it every day, what time it shall run or whatever things we want to do. This is option one, which is simple. And there is a better option for which is fitting our use case, that is, we can refresh this dashboard using our pipeline as well. So let's go there. Let's go to our master pipeline. Here we are. And let's edit it. And if we add a task, so here we can find a dashboard also as a task. And we can name it as like Neobank dashboard. Type is dashboard. Here we can select it, the dashboard we have created, which warehouse shall be used to refresh this dashboard. And if we want to specify any subscriber, those also we can mention here, so that whenever it is refreshed, they will get notification. And we need to add a depends on as well, so that it runs only after gold tables are refreshed. So that's how we can configure it. So yes, this makes our job end to end, from source to silver to gold to sending email and to refreshing dashboard as well. So finally, we can say that this project we have completed. So we understood how we can ingest data from SQL Server using JDBC connection, from blob storage or volume using autoloader, then how we can build various bronze, silver, gold layers. We created delta lake tables. We wrote PySpark reusable code into Databricks notebooks. And this entire thing we orchestrated using our Databricks jobs. And we created our metadata DB as well, where we had the driving metadata, the audit information with all the runs. And to govern this part, we used Unity Catalog, where we created all our tables, jobs, everything. And we send customized emails as well. And to consume our data, we build a really nice Databricks dashboard and a Genie workspace. So that concludes the project overall. And all the artifacts that I used in this project, everything it is uploaded in the repository. And from there, feel free to use it and try it out yourself. And I hope you enjoyed this experience. And if you want to appreciate the efforts I have put in, please put a like and comment on this video. And if you have any doubts, then also please put a comment. You can even set up a one-on-one with me on the top mat. So that's all for now. Thank you. Bye bye. Happy learning.